All right, so we're going to simplify three rational expressions here. Okay, and remember that a rational expression is just a big fraction. Okay, this is a really nice looking rational expression right there. And this one looks just like a fraction. So to simplify, we need to get all of the factors, and any factor in the numerator will cancel with the same thing in the denominator. So let's look at this first one right here. 10 over 25. Now you probably know what goes into 10 that also goes into 25. But the way that I'm going to show this one is like I'm factoring. So if you factor 10, if you take the factors of 10, what two numbers multiply to give you 10? Okay, 2 and 5. And 25, what two numbers multiply to give you 25? Well, that's 5 and 5. And as long as these are multiplied, okay, as long as they're factors, anything in the numerator, any factor in the numerator will cancel with a factor in the denominator. So when you talk about 5 over 5, that's really just 1. It's 1 over 1. And now I'm going to have the simplified version. In the numerator, I have 2 times 1, which is just 2. And in the denominator, I'm going to have 5 times 1, which is just 5. So that is the simplified version of 10 over 25. Let's look at this second problem right here. Now the second problem is super nice because it's already factored for me. All right. This 2 is a factor. This x is a factor. X plus 1 is a factor. 4 is a factor. X is a factor. Y is a factor. Okay, anything that multiplies is a factor. Okay, and then of course this x plus 1 and of course this x minus 2 also. So since it's already factored, let's look in the numerator and denominator. Let's see what's going to cancel out. Well, there's one thing that you notice right here, x plus 1 and x plus 1. That one's kind of sitting there waiting for us. That's pretty obvious. Those cancel out and they both turn into 1s. And there's another thing that you can look at, same thing in the numerator as the denominator, and that's x and x. Now there's one other thing that's going to reduce, and that's the 2 and the 4. So you're going to ask yourself, 2 goes into 2 one time, and 2 goes into 4 how many times? 2 times. So in the numerator, all I'm left with is 1 times 1 times 1. So my new numerator is 1. Now, my denominator is going to be 2 times 1. Let me use a different color here. It's going to be 2 times 1 times y times 1 times x minus 2. So the only thing left in the denominator is really just a 2y x minus 2. And that's what I'm going to be left with. 2y x minus 2. Okay, this is simplified. Now let's look at the third problem. Now the third problem is not factored for me. This numerator is not factored. This denominator is not factored. So I'm going to need to factor it. To factor the numerator, well, numerator and denominator, I'm going to use my best friend. Best friend is the greatest common factor. Look at this. What can I divide out between these two terms? What goes into this term goes into this term. And the answer is a 7. When I divide a 7 out, I'm going to be left with x plus 5. Now look at the denominator. Is it in order? Yes, it's in order. Is there a greatest common factor? Yes, there is. And it's an x. See how I can take an x out of both of these? So to factor the denominator, when you look at it, you might think that you have to do more than you really have to. All you have to do is take out an x, and I will be left with x plus 5. Now this is looking pretty good. I feel pretty good about this because I notice now x plus 5 will cancel in the numerator and the denominator. So what am I left with? 7 in the numerator, x in the denominator.